Okay, all right, so let's continue our session. Okay, so let's start our topic 1, our very first topic of semester 2, topic 1, chemical kinetics. Okay, all right, so chemical kinetics. Let's get an overview of the whole topic first before we proceed further. Okay, so chemicals stand for chemical reaction. Okay, so when we have chemical, it shows that it involves chemical reaction. So in a chemical reaction, we have reactants, we have products. Okay, so a reaction producing from reactant producing products. Okay, and then we have kinetics. So what does kinetics mean? Okay, like we have thermochemistry last time, right? Thermochemistry. So chemistry, we know that it involves chemical reaction. So when we have thermo, that means we want to study, okay, we want to know about the energy involved in the chemical reaction. Okay, all right, same goes to electrochemistry. Chemistry again, okay, referring to a chemical reaction. But when we have electrochemistry there, that means we want to study about the electron transfer when a chemical reaction takes place. Okay, all right. So now we have chemical kinetics. So chemical means we have a reaction. Kinetics, you know that kinetics involve something that have movement. Okay, ada pergerakan dekat situ. So what is it about movement that we are interested in knowing dia punya ciri-ciri, the characteristic. Okay, so when something is moving, what we want to know is how fast or how slow it is moving. Betul tak? Pergerakan dia bergerak, kita mesti nak tahu berapa cepat dia bergerak, okay, how fast or how slow the reaction. Okay, we subject to chemical reaction, right? How fast the reaction proceeds ataupun how slow the reaction proceed. Okay, alright. So when we are talking about how fast ataupun how slow a reaction proceeds, it has something to do with time. Betul tak? Dia ada kena-mengena dengan time dekat situ. Okay, so kinetics relate to time dekat situ. Okay, so how do we measure the time? Okay, kita tak nak focus on the time only, but what we want is the rate. Rate. Okay. Okay, so rate studies about any change in measurement. Change, delta means change in measurement. So the measurement can be anything, okay, over change in time. For example, rate is the general term that we use to describe any change in measurement over change in time. Let's say we specify the measurement in terms of distance, right? Okay, so change in distance over change in time. So this is what we call speed, right? Okay, so speed is actually rate. Okay, because once we have specified the measurement atau the parameters that we are interested in, okay, and divided with time, we have a specific name for the rate. It's no longer, we call it as speed rather than rate, but it's actually rate. Speed ni adalah rate, because rate anything over time. Okay, and then another example, we have weight loss in terms of change in weight over change in time. Okay, so this is called weight loss. This is also rate. Okay, as you can see, we have T there. Okay, all right, we subject to chemical reaction. Okay, what we want is the rate of reaction lah. Okay, dia tak adalah nama dia yang fancy-fancy sikit, the rate of reaction. Okay, so how do we measure the rate of reaction? We measure in terms of the change in concentration. So this is the square bracket is used to represent the concentration over the change in time. This is also rate. Okay? All right, so we have time there to measure how fast or how slow the reaction progress. Okay? All right, so we want to study the rate of reaction. So we're specific to chemistry. Okay, we don't want to study the distance. We don't want to study the weight. We don't want to study the mass. What we want to study is the change in concentration over time. So the time can be hours, can be minute, can be second, can be months. Okay, as long as it is time. The unit can be varies. Okay, all right. So so we want to study about the rate and factors affecting the rate. Okay, so what are the factors that can affect the rate of reaction? So those are apa nama tu compile into this chemical kinetics. So that is the overview of this topic. Okay? Alright, so dapatkan the overview dulu so that you boleh dapatkan dia punya idea lah. Dia ni cerita pasal apa ni chemical kinetic ni? Okay? Right. Okay, moving on. So these are the subtopics that will be covered in this topic 1. Okay, so in total we have 7 subtopics. We're going to start with reaction rates, and then we have factors that affect reaction rates, and then we have rate law, okay, to describe the reaction, and we also have the order of the reaction. Okay, the reaction, every reaction has its own order. Okay, so what is order? Okay, later on will be covered in the slides. Then we have collision theories. Okay, for the reaction to take place, they need to be collided. Okay, they need to collide in order to produce product. Okay, and then the effect of temperature on the reaction kinetics, the effect of catalyst on reaction kinetics, and last but not least, the reaction mechanism. Okay, all right. Okay, let's start with 1.1, the learning objective. So we have 3 learning objectives for this 1.1. Okay, make sure that you cover all of that. Okay, all right, moving on, rate of reaction. So what is rate of reaction? Like I said just now, is the change in the concentration of reactant or a product with time. Is the change, okay, please take note on this. It's not concentration over time. Rate is equal to this. No, this is wrong. It's supposed to be rate is equal to the change in concentration over the change in time. This is very important, change. Okay, that means you should have concentration 1, concentration 2, T1 and T2. So that you can get, you have to minus this value in order to get the change. Okay, so it can be measured in terms of reactant or product over time. Okay, all right. So for the general reaction A becoming B. So this is the reaction A, okay, forming B. The concentration of A is measured at T1 and T2. So this is the duration of time given to us. Okay, so we want to study from A becoming B. So A is the reactant. So how can we calculate the rate of this reaction? Okay, all right, so we know that rate is equal to change in concentration of A, okay, over change in time. Okay, why do we have negative here? Because A is a reactant. Okay, because A is reactant. So by right, okay, throughout the process, the concentration of A will be decreasing, whereas B will be increasing. Okay, all right. Negative, and then if we expand this change in concentration, okay, we will get this one, concentration of A2 minus concentration of A1 divided by T2 minus T1. So this is change, okay? So you have to minus in order to get the delta. So at the end of the day, you will get this one. Okay, all right, you will get this one. You dapat negative A. Okay, the reason you dapat negative here is because A represent the reactant. Okay, all right. So I've introduced to you just now the square bracket indicate a concentration in mole per liter ataupun molar. Square bracket represent concentration. That means it really apa nama tu helps. Okay, so we don't have to every time we want to to represent the concentration, tak perlulah nak CONCNT nak agent, tak perlu. You may use the square bracket to represent the concentration. Okay, alright. So the concentration should be in moles per liter ataupun molar. So unit for rate is mole dm cube and S negative 1, okay, or mole liter negative 1, S negative 1, or mole dm negative 3, minute negative 1. Okay, it depends. It depends on the unit of the unit of the time. Okay, kalau dia bagi unit of the time is second, that means you are going to be using second lah. If the unit is given in terms of hours, that means you need to change into hours lah. Okay, so this is the unit of the rate. Okay guys, okay, so you tak perlu hafal pun. Okay, you boleh derive sendiri kan, nampak tak? Rate is equal to change in concentration over change in time. Concentration, what is the unit for concentration guys? Mole per liter kan? Mole liter negative 1 kan? So T, what's the unit for T? Katakanlah in second. So S. This is the unit for rate. Perlu hafal? Tak perlu. Kalau nak hafal boleh. Tak hafal pun you may derive from the formula itself. This is also the same as molar because this one molar kan over S. Also the same as MS negative 1. You can also replace second with minute, with hours, with months or whatsoever as long as it is time. Okay? Alright. Okay, so again, A becoming B, we can describe the reaction in terms of A. Okay, we can describe the reaction in terms of A, the rate. We can describe the rate in terms of A. But don't forget that we have negative sign there. And we can also describe the rate in terms of B. Okay, because why? Because they are in the same reaction, in the same chemical equation. So we may describe interchangeably depending on the question asked. Okay, all right. So this is the relationship lah that we can get. Okay, so A is if it is a reactant, that means we have negative sign there. It shows that the reactant, the concentration of reactant will decrease over time. Kalau product, kenapa dia positif kat sini? Sebab product, the concentration of product will increase over time. Okay? Alright. This is in terms of diagrammatic. This is in terms of diagram. Yes, ada question?
Madam, kalau bracket tu saya bukan buat macam normal bracket, bukan square bracket tu.
Buat macam mana yang?
Bracket dia tu macam bracket biasa tu lah.
Macam ni? Tak boleh. Itu nak kena jentik dahi tu. Okay? Tak boleh. Dia kata square. Ini normal bracket. Square bracket represent concentration. Other than that, it's not considered as concentration. Wajib okay, tak boleh. Tak boleh. Dilarang. Okay? Alright, bagus tanya soalan tu. Nanti akan ada yang buat. Tak boleh. Okay? Alright. Okay, ini in terms of gambar lah. Okay, alright. A becoming B after a period of time. As you can see, kata this is T0, this is T30 lah, for example. Petik je. Okay, so initially as you can see, we only have A. So all of them are black dots. Okay, initially because we don't have B yet. Okay, so after the reaction progress, after a while, nampak tak? The B started to form. So, B dah banyak lah. Banyak dah B. T30 dah habis reaction. Okay, so that's why dia kata as the reaction progress, A decreasing, B increasing. Okay, so this we can describe in terms of rate for A, okay, and also in terms of B. Okay, how do we transform this in terms of graph, guys? Okay, katakanlah you may represent this as number of molecule and you can also use concentration. Okay, number of molecules should be directly proportional to the concentration. When the number of molecule increases, the concentration will also increase. Okay, all right, over time. So how do we plot the graph? Okay, bila you plot the graph, nampak tak? Yang paling tinggi, the highest concentration would be from A lah. Sebab reactant kan, at T is equal to 0, the reactant will be at the highest. Because this is at the beginning of the reaction. So it starts the highest, whereas product 0. Okay, because dia belum form. Okay, so dia belum form. Okay, after a while, okay, after the reaction progress, as you can see, the concentration of A ataupun number of molecules of A is now decreasing. Kenapa dia decreasing? Because it is being converted into product. That's why they're decreasing. See? Okay, and as for B, nampak concentration of B increasing. Kenapa? Because they start to increase. The concentration start to increase because A is now being converted into B. Okay? All right. Okay, so we can also relate with the stoichiometry. Okay, so differential equation based on stoichiometry. So as you can see, you present that this delta concentration over delta T. This is differential kan? Ini bentuk differential ni. Okay, bentuk differential. So differential equation based on stoichiometry. How do we use this differential equation, the rate, this rate, okay, to be applied in the chemical equation? Because when we have chemical equation, we have stoichiometry. You tak boleh run away from that. Okay, all right. So consider this equation. We have 2A to produce B. That means we require 2 moles of A to produce B, to produce 1 mole of B. Okay, all right. 2 mole of A disappear for each mole of B that is formed. Okay, for each mole of B that is formed. Maksudnya rate untuk rate untuk B form adalah 2 kali ganda A hilang. Betul tak? Ke terbalik? Okay. 2 moles of A disappear for each mole of B that is formed. Yalah. Betul. Okay. 2 mole of A diperlukan untuk B, 1 mole of B terbentuk. Okay. Right. So, macam mana kita nak relate in terms of rate of disappearance dengan rate of formation? Disappearance is for reactant, formation is for product. Okay, alright. So we can equate this rate of A dengan B ni, kita boleh equatekan dia. Okay, so don't forget the negative because A kan dia reactant. So we can the coefficient will be used as the fraction. Okay, so 1 over 2 and then the differential equation for A, for rate A. Okay, and rate of formation for B will be, sebab dia 1 mol kat situ kan, so 1 over 1 plus, kenapa plus? Sebab di produk, so delta B over delta T. Okay, so kita boleh buat this relationship. It's equal to delta B positive delta T. Okay, alright. Let's have another equation here. And so how can we relate all of this in one equation? Okay, so dia ada this chemical equation, so we can transform this into this differential equation. This rate, ni rate untuk A, ni rate untuk B, ini rate untuk C, ni rate untuk D. Okay, don't forget that this is A, we are talking about A now, so you have to have the negative because dia reactant. Okay, so the coefficient will be 1 over A. 1 over A depending on the coefficient lah. A is the coefficient, small letter A. Same goes to B because B is also reactant. That's why we have negative there. Kita boleh equate kan equate means sama dengan kan dia. This is the relationship that you should know. Okay, katakanlah the information is given to us is for A. Dia nak tanya D. So as long as you have this A, you can find out the D. Katalah dia bagi C, dia nak tanya B. Dia dah bagi C. Boleh tak cari B? Boleh. Sebab this is the equation that we have so far that link all of them together because they are in the same chemical equation.
Madam.
Ya. Yeah.
Yang untuk C dengan D tu untuk produk kan, formation kan?
Ya. Yeah.
Tapi kenapa dia ada 1 over C tu? Kenapa dia tak just macam yang kat atas tu, yang rate of formation tu?
Sebab ni satu mol.
Oh.
Ni satu, dia 1 over 1 lah sebenarnya. Sebab kan kita tak tahu C ni berapa kan.
Tak perasan equation kat atas dia.
Okay. So dia depends on the coefficient. Kalau ni satu, that means 1 over 1 lah. So kita tak tahu. Okay. Right. Tak baca apa dah ni. Okay. Alright. So make sure that you know how to transform. Okay, how to transform from this balance equation into this differential rate equation. Okay, and also how to transform from this differential rate equation into chemical equation. Vice versa. Okay, all right. Okay, all right. So that is for differential rate equation just now. Okay, so this is the type of rate. Tu apa rasa ni?
Madam, T dia sama tadi kan?
Apa dia?
T tadi. Dekat yang
T?
Yang bawa yang rate of reaction tu. Bawah sekali tu. T dia semua sama kan?
Sepatutnya kena sama lah. Sebab kalau you study the duration of time pada ketika itu, all of them pun kena study pada ketika itulah. Kalau you study pada first 10 second, and then C dengan D you study pada the last 10 second. Dia tak tally lah kan. Tak boleh macam tu, dia kena pada T yang sama. Then baru kita boleh kata rate dia related. Okay?
Okay.
Okay, nanti kita akan tengok contoh soalan. Contoh dia later. Okay? Alright, so that is differential rate equation. Okay, so this is another part of rate lah. Okay, we have few types of rate. We have initial rate, we have instantaneous rate, and we also have average rate. For this type of rate, sebenarnya, you have to draw. Okay, you have to construct a graph. That means you have to use a graph paper in order for you to construct the graph. Okay, all right. So initial rate, instantaneous rate, average rate. So how do you calculate the rate? Okay, all right. So ni kita akan tengok contoh. Ini contoh graph dia nanti. Okay, all right. Initial rate, the word initial, that means at the beginning. So that initial. Okay, rate at the beginning of the reaction computed from the slope of line tangent to the curve at T is equal to 0. That means T mesti equal to 0. And then we would call it as initial rate. Okay, kita panggil dia initial rate. Maksudnya rate at the beginning of the reaction. Apa yang you kena buat adalah, okay, macam ni you will be given a set of data. Okay, you akan dibagi set of data. Macam tadilah soalan yang tadi tu kan. Okay, dia bagi you concentration and you bagi time. Bagi berapa. So from this data, you are required to construct a graph. Okay, you can construct a graph dulu. And then from the graph, you will be asked to find initial rate, instantaneous rate, and also average rate. Faham tak? Okay, alright. So first step, when you get this data, you have to have your graph paper. Okay, so you have to plot a graph, concentration, versus time. Okay, and then you kena plot lah ni concentration versus time kan. This is X, this is Y. Okay, so you pun plot. Bila you plot, you akan dapat, katakanlah you akan dapat curve. You akan dapat curve. Sebab concentration versus time, you akan dapat curve. So katakanlah you connect best fit, okay. Alamak. Macam itulah. Okay. Buat macam cantik graph. Make sure you practice buat graph ni sebab dalam exam kita common question juga. We give student this type of question where you are required to plot a graph. So kalau you tak biasa buat dari sekarang, you terhegeh-hegeh lah macam mana nak cari the skills, okay, how to plot a graph. So lambat dia tu. So please make sure that you practice from now. Okay, so you plot a graph. So there you go, you have your graph ready. So kat situ you dah dapat 2 markah dah kat situ. Okay, alright. So lengkap semua, label all the axes and all the plots are there. So you dapat 2 marks there. And then soalan tanya, calculate the initial rate. So macam mana you nak calculate the initial rate? Okay, alright. So what you need to do is you have to draw, kata apa? From the slope of line tangent to the curve at t is equal to 0. Okay, so you identify t is equal to 0 is here. Okay, so make sure t is equal to 0 yang kena pada curve. Mana kena pada curve kat sini? Dia dah saya ingat sikit, minta maaf ya. Okay, sini kan. Sini. This is t is equal to 0. So dia kata buat dot tu dulu. And then from there, you compute a tangent line. Maksudnya ni dot, you kena buat tangent line that pass through the dot. The best tangent line Okay, macam nak buat best tangent line, make sure that it is the closest to the curve. Okay, tu pun ini pun kena belajar juga. Jangan buat tangent line mengarut-ngarut macam tu, macam ni. Tu yang you akan dapat, you punya baca, you punya value berbeza dengan kawan-kawan you yang lain. Skill membuat graph is very important so it will affect your values later on. Okay, alright. So buat tangent and then you got your tangent already. Okay, find out the slope. The slope of this tangent, because the slope of this tangent, macam mana nak calculate slope of tangent? Slope is equal to change of y, betul tak? Change of y over change of x. As you can see, y ni siapa? Concentration. The change of concentration over the change of x ni apa? Time. Bukan ke ni rate? Bukan ke the slope represent the rate? Kan?
Yes, madam.
So the slope represent the rate. So the reason it is called initial rate is because you buat tangent tu pada t is equal to 0. So jangan kita madam, mestilah 0 madam dia punya rate sebab over 0 kan? Siapa kata? Siapa kata? Macam mana nak cari tangent, nak cari slope untuk tangent, you kena ada 2 point kan? Janganlah terus je kosong kat situ cantik dahi juga. Okay. Alright, so please make sure that you know how to calculate slope for tangent line. Okay, alright. So that is for initial rate. Okay. Instantaneous rate. The word instantaneous, at that instant of time. Okay, rate for specific instant in time. It can be obtained by computing the slope of line tangent to the curve at that point. Maksudnya at any point, at any instant. Okay, saya rasa saya nak check lah rate at t is equal to 5 minute. Kan? 5 minute. At that instant. So what you need to do is katakanlah this is 60 minutes kan. 5 minit kat mana kat sini? Okay, you pergi ke atas. Cara macam mana nak dapatkan rate dia tu, that instantaneous rate at t is equal to 5. Okay, so this is the dot. Draw a tangent again that pass through this dot. Lebih kurang lah macam tu lah. Awak buat cantik sikit kan. Okay, so dapatkan dia punya slope sama juga, which equal to rate. Okay, which is equal to rate. Cuma dekat sini, ya betul. Which is equal to rate. Okay, so this is what we call instantaneous rate at t is equal to 5. Boleh juga at t is equal to 30. Sini. Buatlah. Ni dia punya dot, lepas tu buat line. Okay, then find out the rate. So this is instantaneous rate also. Alright, okay. Last but not least, average rate. Okay, it is defined as the rate change at any particular time period. At any particular time period. That means period. We have a duration of time. Nampak tak? Kita ada duration of time. Apa beza dia initial rate and instantaneous rate? Instantaneous rate dengan initial rate, dia dah ada specific time. Dia tak ada duration. Dia nak, okay, I want it to be at t is equal to 5 minutes. I want to know what is the rate at t is equal to 5 minutes. But for average rate, is after a period of time ataupun duration dekat situ. Okay, alright. So contohnya, kalau soalan tanya, calculate the average rate at at 400 second. Maksudnya t is equal to 0 until t is equal to 400. This is the duration. Maksudnya t is equal to 0 sampai 400. Boleh juga katakanlah, okay, please calculate the average rate starting at t is equal to 5 sampai t is equal to 400. Minit kelima baru kita nak check dia punya rate sampai 400. That is also average rate. Because why? We have duration of time. Bila ada duration, that is what we call average rate. Okay? Alright, so there are two ways to calculate average rate. One, paling senang sekali kalau soalan tanya throughout the experiment lah. Calculate the average rate throughout the experiment. Saya pakai kali hijau. Okay, you can simply get it from your data. Katakanlah ni T0 kan, ni T400. So you dah ada dia punya concentration at 0, concentration at 400, you minus this 2, minus this time, then you dapatlah the average rate. Betul tak? Another option if you are asked to use your graph to find the average rate, you know macam mana? Katalah again 0 sampai 400. Macam mana you nak use your graph to find the average rate? Okay? So by right you kena ada 2 point. Satu at 0. Satu at 400. Katalah ni 400 Okay. Next, you connect these 2 points. You find out the slope. The slope represent the rate. Okay? Dia tak semestinya kosong dengan 400. Boleh juga tiba-tiba dia nak dekat sini. Dekat 5 ni kan. This one. Dekat 5 dengan dekat 30. Average rate dekat situ. Berapa rate dia. So you connect these two. Find out the slope. That will be the average rate from 5 to 30. This is what we call duration of time. Okay? Alright, so it all depends on the question. If the question asks you to find the average rate using your graph, that means you have to use your graph. Okay? If soalan tak cakap, that means tak payah penat-penat lah pergi buat kat graph tu. Pergi ambil data daripada table. Tu pun kalau boleh. Okay, kadang-kadang memang kena guna graph. Kita design soalan tu so that you must use your graph in order to get the final answer. Okay, what else? Ada tadi nak cakap apa? Ya, tu je lah kot. Yep. Okay, ni lah contohnya. Okay, alright. This is example. Okay, you have to plot the graph. Okay, this is the data given. Okay, data given, and then you have to plot the axis x and y. Plot the curve first. This is the curve that you get, and then katakanlah soalan suruh calculate the initial rate. Okay, that means at t is equal to 0, you have to draw the tangent line that passes through the dot, the yang dot kat situ, yang 0 tu Okay, kat 0 tu. So baru you cari dia punya slope. Initial rate ni. Berapa ni? Kira tak kira ni? Saya tak kira je. Dia tak kira ni. Dia suruh you kira sendiri. Okay, you kira. Ni sebenarnya kena kira, bukannya 0. Bukan jawapan dia 0 Bukan jawapan dia 0. Dia kata rate at 0 second berapa. Cari. Sebab dia depends on your punya tangent line. Betul tak? Alright. Oh, lupa saya nak cakap tadi yang ni kan. You boleh compare, okay? Using for average rate just now, you can compare the one that you got from the data. Okay, you calculate the average rate from the data and then you compare with the one that you got from your graph. Kalau you dapat beza dia sangat-sangat kecil, that means you punya graph very, very good. Okay, you punya graph is very, very good. That means in terms of scale bagus, in terms of best fit bagus, semuanya bagus. Kalau you dapat dia punya gap dia terlampau beza sangat, there's something wrong with your graph. Okay, provided yang lain, faktor-faktor lain tu semua perfect lah. Okay. Okay, alright. So this is an instantaneous rate at 100 second, at 200 second, at 300 second. These are all instantaneous rate. In fact, initial rate is also instantaneous rate. Do you guys agree with me? Instantaneous rate is also initial rate. Initial rate is also instantaneous rate. Agree ke tak agree?
Agree.
Seorang ni, yang lain semua tak agree.
Agree.
Okay. Agree tak? Sebab instantaneous rate at that particular of time. Which is kalau 0 second ni, kat at 0 lah. Mesti at 0. Yang ni mesti at 100. Mesti kat 200, 300. Which is dia instantaneous rate. Tapi dia special sikit. Dia ada nama dia sendiri because dia mesti dekat beginning. So, kalau instantaneous rate, it can be anywhere, right? Tapi kalau initial rate, it must be at 0. Dia adalah sejenis instantaneous tapi must be at 0. Therefore, it is being called initial rate.
Madam.
Yeah.
Tapi kan madam, sebab dia kan, dia punya graf kan itu, apa ni, lengkung. Jadi, bukan sepatutnya dia punya kecerunan tu lain-lain ke madam?
Kecerunan dia lain-lain? Yalah. Kecerunan dia lain-lain. Lain. That's why kita kena buat tangent banyak kan. Kita kena buat tangent dia banyak.
Maksudnya initial rate tu dia akan sama lah dengan instantaneous yang lain lah.
Tak sama. Tak mungkin dia sama sebab dia curve kan. Sebab nampak tak? Even kat sini at 100, 2.96. This one 2.09. This is 1.48. Dia different. At different time, the rate will be different. Okay? Yang kita tahu, dia of course, dia decreasing confirm sebab we are talking about reactant. Tapi kita tak boleh pukul rata that dia mempunyai rate yang sama. Kalau rate yang sama, dia macam gini. Dia straight line dia. Okay? Tapi dia bukan ke bawah. Dia bukan straight line. Dia bukan straight. Dia curve. Bila dia curve, bila kita buat tangent, of course dia punya slope will be different at every point. Betul tak? Logiknya.
Betul.
Okay.
Okay.
So madam, kalau instantaneous rate ni, kita kan kira slope of tangent dia tu. Jadi kita bahagi, contoh macam kita ambil yang ni, 100 second kan. Jadi kita kena bagi dengan 100 second ke apa? Tak kan?
Bukan. Kita bukan bagi dengan 100 second. Kita kena cari slope tu macam kita cari slope sebab kita nak cari for this tangent kan. Cuma kita buat 100 at 100 second which is kat sini sebenarnya. Tu that's why saya ajar awak tadi. You buat dot dulu. Dot dia kat mana? Okay, sini. Ni dot dia kan. Lepas tu next step will be you draw tangent line yang pass the dot. Okay. Baru you boleh cari dia punya slope dia tu. Ini kita consider at 100 second. Kenapa kita kata 100 second? Sebab kita dah lalu that dot at 100 second tu.
Okay. Jadi kalau tangent line tu saya buat besar, jadi besar dia punya bacaan dia.
Sepatutnya lah. That's what, kalau you buat panjang ni kan. Kalau you buat panjang macam ni, dia punya slope memang sama sebab dia straight line, betul tak? Dia straight line. Slope dia memang sama. Tapi the more you deviate from the curve, you menjauhi curve tu. Faham tak? Bila you jauh daripada curve tu, that means the more the value will be deviate more. That's why saya advise you, okay, rasanya you lagi tahu kot macam nak buat the good tangent kan. Saya rasa the best would be the closest to the curve line tu. Lagi dekat dengan curve tu. Bila buat slope tangent tu, maksudnya cari slope dia, dia punya graph tu, garisan dia tu should be the closest to the, nak cari point tu, nak cari slope tu nanti. Closest to the curve. Okay?
Jadi macam initial rate pun kita kena kira slope of tangent kan? Initial rate.
Tangent, Because kita ada curve. Kita tak ada straight line. Jadi cara nak cari dia punya tu adalah dengan buat tangent. Nak cari slope mesti kena ada tangent. Kena ada straight line kan. Jadi kita ada curve. Macam mana nak cari slope kalau tak ada tangent. Jadi kita draw the tangent. Okay? Alright. Okay, so this is the average rate. Okay, this is the average rate. Average rate. T0 minus 400. So this one you can get from the data itself. Tapi like I said, cuba practice, you connectkan the 0 and the 400. Connectkan these two line. Okay, connect straight line Jangan jadi curve lah. Straight line saya tak boleh lah sebab freehand ni kan. Okay, try compare value you dapat tak dekat-dekat. Okay, alright. Okay, and then one more thing guys. Apa ni? Alright, kat sini kan tadi dia ada ni kan. Nak calculate the average rate, this is the formula, okay. One more thing that you should know, the value of rate, maybe you boleh tambah kot dekat earlier slide tu. The value of rate, the numerical value of rate. Numerical means number, value. Contohnya 4.4 darab 10. Tu value, numerical value. The numerical value of rate will always be positive. Okay, will always be positive. Okay, so the reason kita ada negative kat sini, like I said, because the reactant tadi kan, that's why we have the negative there. And then, as you can see, you nampak tak dekat sini, because of this negative, you akan dapat the final answer will be positive. Because bila ni tolak, sini value dia dah negatif, betul tak? Sebab yang kecil tolak yang besar. You patut dapat negatif. Okay? Tapi because we want it to be positive value, like I said just now, the numerical value of rate should always be positive. Okay? When you have negative, you should transfer to the other side. Later kita akan buat differential kejap lagi. Okay? That shows that it is a reactant. Okay? So that is why you akan dapat here, the value is positive. Even though we are talking about the reactant. So kat sini menunjukkan macam mana cara you nak baca ni. Okay, bromine, the rate of disappearance. The rate of disappearance of bromine is 2.26 times 10 to the power of negative 5. Okay, ataupun you baca the rate of bromine is decreasing at a rate of 2.26 times 10 to the power of negative 5. Because you tahu dia adalah reactant, betul tak? So that's why kita kata decreasing. Okay? Alright. So we are done with the graph tadi. Itu dia mana nak cakap tadi? Tadi just now we have this one. And this is the differential equation. Okay, yang ni kita akan ada example sebentar lagi menggunakan this equation later on. Okay, and then tiba-tiba kita kena belajar buat graph. Okay, you have been introduced to several types of rates. Ni graph, ni cerita graph lah. Ni dia tiba-tiba dia masuk cerita ni, and then ni is the example of the differential rate just now, yang equation tadi tu. Okay, alright. Patah balik sikit. Okay, let's look at the example. Okay, saya ada make some modification on the slides, especially for the solution. Okay, you may notice ada difference sikit in terms of the relation, in terms of the solution, but it is not wrong. It's just that I find it easier, okay, to use this method rather than the one that you have in the lecture notes. Okay, so I'll explain why. Tak apa, you boleh compare. Dia tak salah, dia tak ada masalah pun. Dia boleh pakai. Cuma this is another option that I feel it's easier to understand. Okay, alright. So let's go through the question first. For the reaction given, the I minus changes from 1 molar to 0.868 molar in the first 10 seconds. Okay, calculate the average rate in the first 10 seconds. Please take note that when you are calculating for rate, it must be change in concentration over change in time. Okay, so we can observe that from here. So we can calculate the change of concentration because we have the concentration 1 and concentration 2. You can simply minus these two. How about the delta T? The delta T is also, we need two time dekat situ. Okay, because we want it to be the product of delta T, the minus product of delta T. The minus product of T. Alright, bila dia cakap 10 second ni, maksudnya understood tau. Bila cakap first 10 second, T1 dia will be 0, T2 dia will be 10. Then you can simply 10 minus 0. Dapatlah 10. Faham? You mesti dapatkan delta T. Dia bukan concentration over T ya, dia delta concentration over delta T. Okay, so bila 10 second ni, it is understood that dia daripada 0 until 10. Tu, begitu ceritanya first 10 second. Bukan dia T saja ya, dia sebenarnya delta T. Alright, so let's go for, dia ada dua soalan dekat sini. Calculate the average rate in the first 10 second. That will be the first question. Okay, because this one with respect to I minus. And then second question, you have to calculate for delta H plus. Okay, for delta H plus delta T. Okay, let's go for question number 1 first. Okay, so the equation is given. All right, so what you need to do is rate is equal to, because this is a reactant, right? So you have to have the negative there. And then you have the coefficient 1 over 3 delta I minus over delta T. Okay. Alright, because without this one, this is only the rate at that particular time. Kita tak tahu stoichiometrically dia. Kalau you just ambil ini saja, ini tak involve stoichiometry. Kita just masa buat dekat lab tu, okay, saya nak tahu initially dia punya concentration 1 molar. Okay, after 10 second, 0.868 molar. Tapi in terms of stoichiometry, we don't have that information. So we have to do the calculation. Okay, so that's why when we want to know the rate with respect to this reaction, you have to include the coefficient. Faham? Okay, so you have to include the coefficient. So since I minus is the reactant, so you have to include the negative sign there. Okay, and then you minus T2 minus concentration 2 minus concentration 1, 10 seconds. So this is delta T. So you got this one. Because this one, dia punya product dia, you akan dapat negative value. So negative dengan negative cancel out, you akan dapat positive value. Like I say just now, the numerical values for rate, regardless whether it is reactant or product, it should always be positive. Okay, rate, numerical values should be positive. Okay, okay, so we are done with I ini, the average rate for first 10 seconds for I. Okay, let's change color. Soalan nak tanya delta H plus over delta T. Okay, all right. So by use, they are in the same equation, right? So how do we relate these two? Okay, so we have the differential equation just now. Kita pakai dia punya coefficient tu, and as you can see, both of them are reactants. So don't forget dia punya coefficient. So this is for H plus and this is for I minus. So 1 over 2 negative, don't forget the negative because both of them are reactant. Okay, kita buat dulu dia punya equation tu. So this is the relationship that we can get from the balance equation. Okay, now moving on. Kita nak tahu H plus kan? But what we do know, apa yang kita dah calculate is this one. So that, which is this. This whole thing is equal to 4.40, right? Including the negative sign here, all of this is equal to 4.40 yang kita dah calculate tadi tu. Just now. Okay? So it's equal to this. And then we have this. What we want is this one. Okay, what we want is this one. Okay, so you may transfer the whole negative to transfer to the other side. You akan dapat negative 8 macam tu kan. Okay, so like I said, numerical values for rate should be positive, right? So you transfer the negative sign to the other side. And let it be positive value there. But you do have negative on the other side to remind you that this is reactant. Okay, this is reactant. So this value shows that the H plus decrease at a rate of 8.8 times 10 to the power of negative 3. Okay, dekat dalam you punya lecture rasanya dia tulis negative 8.8 kat situ kan? Betul tak? Betul ke tak betul?
Betul, madam.
Betul, madam.
Okay, alright. Sebab last time we do have that statement in the earlier slide. Dia kata dekat situ the numerical values for rate will always be positive. Tapi sekarang dia dah remove. Okay, tak apa. Kalau you dapat the negative kat situ, you transfer to the other side. Okay, the negative shows that it is a reactant. Tapi kalau produk you tak patut dapat negatif you jangan simply abaikan dia ke apa. You patutnya positive value. Okay? Alright. Alah, ada satu lagi kelas. Guys, do you have class after this? S13?
No, madam.
How about S14?
Tutur dengan madam.
Tu pukul 6 kan? Pukul 5 kan?
Oh tu tapi sejam tinggal.
Saya nak masuk satu checkpoint je ni. Boleh tak?
Okay.
Boleh tak? The rest guys yang lain. Tanya orang yang
Boleh.
boleh sebab saya nak tinggalkan awak dengan checkpoint yang lain. Jadi awak kena betul-betul faham lah checkpoint ni supaya awak boleh buat the next checkpoint. And tutorial. Okay, jom buat ni. Question 1. Okay, jom buat sama-sama lah. Tak sempat nak tunggu buat. Okay. Dinitrogen pentoxide N2O5 decomposes. Maksudnya dia terurai, dia degenerate. Okay. So this would be the reactant. because the word decomposes to form nitrogen dioxide and oxygen. So this is the equation given. See the information given, okay? Right, NO2 is produced at a rate of 5.0 times 10 to the power of negative 6 molar per second. Calculate the corresponding rate of disappearance of N2O5 and the rate of formation of O2. So there are two questions there. Okay? All right, so the only information given to us is this. This is the only information given to us for NO2. And we know that NO2 is the product. Right? Okay, if we could translate this, okay, into rate, into differential rate. Okay, alright, sabar dulu, sabar. Madam tenang sekejap Okay, so ini information yang dia bagi. Soalan yang kita nak adalah N2O5. So how do kita buat satu-satu dulu lah, okay? Okay, NO2 dengan N2O5 dulu. O2 second question. Okay, how do we relate NO2 and N2O5 from the equation? Okay, so we can relate that 1/4 delta NO2 over delta T. Okay, because the product, remember NO2 is the product kan, so the plus. So saya tak tulis lah plus tu. Is equal to, because we want to look for N2O5. So N2O5, we have negative sign there. 1/2 delta N2O5. Delta. So this is the relationship that we have between NO2 and N2O5. If we have the information for any of these two, we can get the information for the other one. Katakanlah kita ada information for NO2, definitely kita boleh cari N2O5. Okay, alright. So this is the information from the differential equation yang kita dah belajar so far, from the balance equation. Okay, don't forget the negative sign because N2O5 is the reactant. Alright, so what is given to us? Ni, 5. So how do we translate this, guys? This is rate, right? Okay, so NO2 produced at a rate of 5.0 times 10 to the power negative 6 molar per second. So this is actually delta T, delta NO2, delta T is equal to 5.0 times 10 to the power of negative 6 ms negative 1. Betul tak? Saya just translate apa yang dia bagi ni dalam bentuk rate. Dia cakap ni rate. Ni lah rate which is produce kan. Plus lah dekat sini. So what is the rate? This one. Okay. So without the coefficient, okay, without the coefficient, because we are talking about rate only. Okay, so this is the information given. So kita ambil this information, masukkan dekat dalam apa yang kita ada ni. Bukankah this one is the same as this? Sama kan? So, sama kan atas bawah tu? 1/4. So saya pun masuk 5.0 times 10 to the power of negative 6 ms negative 1. Okay, is equal to 1, 2 delta, alamak. Buruk lah tulisannya. Alright. Okay, so you transfer to the other side. Okay, you transfer to the other side. Katakanlah kan, you bawa lah semua ni pergi ke sana lah. Bawa ke sana kan. So 1/4 times 5, 0 times 10 to the power of negative 6 molar. Unit guys. Jangan lupa. Okay, so negative 2. Okay, alright. Remember, numerical value should be positive. So you transfer this negative just now. So the answer will be 2.5 times negative 6. Negative tu transfer to this side. Alah, nak tulis kat mana? Ni lah. Okay, logic tak? Logic. Sebab we are talking about N2O5. and this is reactant. So when we have the negative sign there, it shows that it is a reactant. Okay? Is a reactant. So dia ada negatif tu kat situ that menunjukkan dia adalah reactant. Tapi you transfer to the other side lah. Dia tak major lah. Kalau you ada kat sini pun dia taklah critical. Tapi like I said, sepatutnya value dia tu kena positif. So you transfer to the other side so that the numerical value tu must always be positive. This one kat sini tak apa. Tak ada masalah. Okay? Alright, so cuba tengok. This is the one lah. Dia punya answer. Okay? So maintain macam ni. How about the product, the oxygen just now? Oxygen is the product, betul tak? Oxygen is the product. So bila you nak calculate for product, you pula guna information product and O2 is product, O2 is product. So tak ada isu negatif-negatif dekat situ Tak ada isu negatif-negatif di situ. So patutnya you memang positif-positif, end up positif. Ataupun another option would be the negative cancel out with negative. Okay? Negative cancel out with negative and you still get positive value. Faham? You jangan you product tapi you dapat negatif value, lepas tu you abaikan. You hilangkan. Don't do that. Okay? Because that is not mathematically supported. Dia tak boleh. Chemistry kena mathematically supported. Okay? Alright. So that is all. So we have 2 more checkpoints. So please complete the checkpoint. Okay, we will discuss. Tak tahu bila kita akan decide on our replacement lecture. Okay, later. Alright. So far okay ke?
Tadi kenapa benda kata yang negatif tak boleh ni? Tak payah transfer?
Yang mana? Bila saya kata tak transfer?
Yang pergi kat answer ni, yang das delta N2 O5 tu.
Ni, this one.
Itu.
This one. Sebab kan saya kata tadi, kan saya suruh tambah dekat notes awak tadi, that numerical values tu, okay, the numerical values for rate should always be positive. So kalau you letak kat sini negatif, tally tak dengan statement tadi tu? Tak tally kan? Sebab dia dah negative values dekat sini. So dia conflict dengan statement yang kita ada tadi, yang kita kata the numerical values for rate should be positive. So nak make sure dia tally, so what we do is kita transfer the negative ni, kalau sini ada negatif, you transfer to the other side. So sini akan negatif, sini dah tak ada negatif kan? Betul tak? So dapatlah kita maintain statement tadi tu, the numerical values for rate should always be positif. Faham tak? Taufik kan tanya tadi kan? Taufik? Dia tak critical lah, as in ni dia tak critical. Kadang student dia terletak dekat situ kan, 2.5 macam tu kan. So far kita tak critical sangat lah on this. Tapi itulah, dia tak tally lah dengan statement yang kita ada tu. So tak best lah macam tu kan. Okay, dia punya konsep dia tu. Okay? Alright. Ada soalan lain lagi? Tak ada. Okay, tak ada. I think that's all. For S14, you punya tutorial pukul 5 hingga pukul 6. Dia yang paling awal lah. So macam biasa kita tak cover banyak. Buat sampai yang mana awak tahu ataupun kita buat sama-sama. Okay, it's best for you to try dulu. You have 1 hour kan. Buatlah sampai yang mana. Rasanya buat soalan nombor 1 ke nombor 2 macam tu kan. Try. Okay, kita akan discuss sama-sama. Untuk this first week je. Next week kena prepare before tutorial. Okay, kena submit macam biasa. Alright, okay. So thank you everyone for your kind attention and Assalamualaikum. See you guys later. Bye-bye.
Thank you, madam.
Thank you, madam.
Thank you, madam.